Good morning, dear students. My name is Ferhan Mazher, and today we are studying the subject Cambridge O Levels DMaths 4024. We are working on the syllabus and we are working on the application of the trigonometry, and we are working on three-dimensional story sums or problems or word problems. Especially these three-dimensional problems, they are related with the angle of the elevation and the angle of the depression. And in some cases, we also have to find the unknown signs. So we will have in this exercise 3D models, and we have to apply the simple trigonometry, and we have to solve. We have to find out the different angles, and we have to find out different sides, unknown sides. So this is my second video on this exercise. This exercise is exercise 9C from the book D3. The name of the book is New Syllabus Mathematics 7th edition, and this is the book which we are using to cover the syllabus contents of the DMaths 4024. So this is New Syllabus Mathematics 7th edition, book 3. And this is the second video. In my first video, we have done from question number 1 to question number 6. In this video, we are going to try to solve from question number 7 to question number 12. So let's start today's work. So question number 7 showing up on your screen. I hope you can see this. In the figure, the ABPQ is the rectangular sloping surface of a desk with the ABCD lying in a horizontal plane. Q and P lie vertically above D and C. So this is like a ramp, okay? So the ABCD is the base of that ramp, which is horizontal, and the inclined surface, which is a rectangular surface, ABPQ, that's a rectangular, that's the surface of that ramp, and the P is vertically above the C and the Q is vertically above the D. So it's a ramp. So you can consider ramp. Given that AB and the PQ, they both are equal to each other and they both are equal to 90 centimeter. The AQ side and the BP side, they both are 75 centimeter, and the angle PBC and the angle QAD, they both are equal and they both are 25-degree. Find. The first question they ask you is to find the AC length. The AC length. Okay. So very easily I can find out the AC length, but it's a two-steps calculation. You see, this BP is 75 centimeter. This BCP is a right angle triangle. So basically, we want to find out AC. For finding the AC, first of all, I know this side. I need to know what is the BC side. If I know the BC side, I will apply the Pythagoras and I will get the AC. For finding the BC, I will consider this triangle. BCP, which is a right angle triangle. I know the BP, that's 75. I know this angle at the B, that's 25. So this is a two-step calculation. So first of all, we'll find the AC. Okay, so you can see here, I have taken out the triangle BCP, and the BP is 75, that angle is given. So I will apply the cos. Cos 25 will be equals to base by hypotenuse. So base is BC, hypotenuse is 75. So the BC will be equals to 75 multiply the cos 25, and that BC will be equals to 67.97 centimeter. So once I know the BC, then you know that ABC is a right angle triangle, and that is at the horizontal, and at B the angle is 90. So I know the AB side, that's 90 centimeter. I know the BC side, that's 67.97 centimeter. So I can apply the Pythagoras here. I want to know the hypotenuse. So the AC square will be equals to the 90 square plus the 67.97 square. So AC will be equals to square root of that 90 square plus 67.97 square. That is 12719.9. take its square root, that will be 112.78. So when you round it off, it will be 113 centimeter. So this is how you will do the first part, AC. And I hope you understand this. Okay, so the next thing they ask is find the angle PAC. So this PCA is a right angle triangle. So at the angle the angle C will be 90. PCA angle will be 90. I can find the PC side. I know the AC side. I can find the PC side from the right angle triangle PBC. I know this side. I know this side. Applying Pythagoras, I will be able to find out the PC. Once I know the PC, then I can apply sine, cos, tan, something, and I can find this angle PAC. Okay, so let me show you. Okay, so the first step in the calculation, I will take the triangle PBC, and I know the BP is 75 centimeter, and the BC we just calculated in the first part, that's 67.97. So I will apply the Pythagoras, and I will find out what is the PC. That's the height of that ramp. So the PC square will be equal to 75 square minus 67.97 square. So PC will be equals to PC square will be equals to 1005.08. Then I will take the square root on both the sides. So the PC will be equal to 31.7 centimeter. Once I know the PC, then I can take out that triangle. The triangle is APC. At the C, the angle is 90. P is vertically above the C. I know the AC length. We've calculated in the first part. That is 113 centimeter. We just calculated what is the PC. That's 31.7 centimeters. So right angle triangle. I want to know this angle, the side opposite to the angle. That side is known as, in here in Pakistan, we call it the perpendicular. Some people call it the opposite side. And we know the base, the adjacent side. I can apply tan. Tan is perpendicular by base. So the tan PSC will be equal to the perpendicular by base. The perpendicular is 31.7 and the base is 113 centimeter. So the PSC angle will be equal to the tan inverse of bracket start 31.7 divided by 113 bracket close, and in your calculator you will get the answer 15.7 degrees. So the PSC angle will be 15.7 degrees. So this is the second part, and this is how you will do this question. The next question, they ask us to find out the CAB angle. So this triangle ABC, which is a right angle triangle, we know all the three sides of this triangle. And I want to know what is the angle CAB. So I can apply the law of cosine, or it's a right angle triangle. We don't even need law of cosine. So we know the three sides, it's a right angle triangle. And so I will apply tan CAB equals to perpendicular by base. You know the perpendicular here is 67.97 and the base here is 90. So tan CAB is equal to 67.97 divided by 90. So the CAB will be equal to tan inverse bracket start 67.97 divided by 90 bracket close. And the CAB angle will be 37.1 degrees. So this is how you will do the third part, and this is how you do the whole question number. Let me reduce the size of this slide, and I hope you can see the whole question. Okay, so the whole question is showing up on your screen. What you can do, you can pause your video, and you can take whatever time you like to have with this question. I'm going to the next question. Okay. So the next question coming up on your screen is question number 8. Okay, so in the question number 8, he says, in the figure, a cuboid has a horizontal base. So it's like a box, it's like a room. G, F, E, H are the four corners of that box or room on the floor. And C, B, A, D is like the roof of the room, the top of that box. C is exactly above the G, B is exactly above the F, A is above E, and D is above H. So you can consider it like a room or like a box, and then it will become easy for you. In the figure, a cuboid has a horizontal base EFGH, where HG is 15 centimeter, GF is 8 centimeter, and the BF is 7 centimeter. X is a point on the AB such that XB is 4 centimeter. So on the roof from B, if you go towards A, 4 centimeters away from the B is a point X. Okay. So first question is find the CEG. Okay. So I want to find out the angle CEG. If you join C with the E and the G, the angle EGC will be 90 degree. This CG height will be 7 centimeter. But first of all, I need to know how much is the EG. EG is the diagonal of the rectangle EHGF. So I can find out, I know it's 2 dimensions, so I can find its diagonal. So first of all, I will find that. So once I know the EG value and I know the CG value, then I can find that CEG angle. It's a 2-step calculation, so let me show you. So here we go. So we are basically talking about the exercise 9C, and we have the question number 8, that is CEG angle. We want to find out the C. That's the basic question. The first step, I will take that rectangle, which is the floor, and I will join E and G. I know the sides of that rectangle, and I can apply the Pythagoras, and I can find the diagonal EG. It's a right angle triangle. EHG is a right angle triangle. So EG square is equals to 15 square plus 8 square. So EG will be equals to 15 square plus 8 square is 289. So take the square root of the 289. So EG will be equals to 17 centimeter. So this is how we can find the EG. And once I know the EG, then I can take the other triangle, and that triangle is EGC. The CG side is 7 centimeter and the EG side is 17 centimeter. And I want to know the CEG angle. So it's a right angle triangle. I want to know that angle. The side opposite to that angle is 7 centimeter. The base is 17 centimeters. So apply the tan CEG. That will be 7 divided by 17. And the CEG angle will be tan inverse bracket 7 by 17 bracket close. And the angle will be 22.4 degrees. So this is how you will find. It's a 2-step calculation, and I hope you understand. So the first part of the question number 8 is showing up on your screen. And we have taken 2 different triangles, and by using the 2 different triangles, we are able to find out that angle. So this is how you will do this question. So let's go to the next part. In the next part, they want us to find out the GXF angle. The GXF angle. So this angle also requires, we have to do it in the 2 or 3 steps. To see if you look at the triangle GXF, okay? So I want to know that GXF angle. So first of all, I need to know how much is the XF. So if I join this is join X and F. So XB is 4 centimeter, the BF will be 7 centimeters, so I will find XF, okay? Then I will join the G with the X, and exactly below the X on the EF line, exactly below the X on the EF line, I will have X prime, a number X prime. So I will join G with the X prime. So I will apply the Pythagoras on the X prime FG. Exactly below the X on the EF line, I will have a point X prime. I will join the X prime with the G. So the GX prime F will be a right angle triangle. So I know the X prime F will be 4 centimeter. The GF will be 8 centimeter. So I can find the GX prime by applying the Pythagoras. Once I know the GX prime, then I know the XX prime will be 7 centimeter. And the GX prime, I know the value, then I can apply the Pythagoras and I can find the GX. Once I know the GX and the FX and the GF, by applying the law of cosine, I can find the angle GXF. This is the strategy of solving it. And let me show you how this is executed. Okay, so first of all, we are going to take the triangle XBF. The XB is 4 centimeter. The BF, which is the height, that's 7 centimeter. It's a right angle triangle. So apply the Pythagoras. So you will have XF. So XF whole square will be equal to 4 square plus 7 square. So the XF will be 8.1. So we took the, how this is done. And then I will use this triangle. It's X prime FG. So the X prime is basically exactly below the X on the EF line. So the X prime F will be also 4 centimeter, and the G, that's 8 centimeters. So it's a right angle triangle. So I will apply the Pythagoras here on the X prime G. So X prime G whole square will be equals to 4 square plus 8 square. That will be X prime G will be equals to 8.9 centimeter. So once I know this, and then I will consider the triangle, this triangle, G X prime X. X prime is a point exactly below the X. So this height X prime is 7 centimeter. The G X prime we just calculated, that's 8.9 centimeter. So I will apply the Pythagoras here and I will get the value of the GX. So the GX whole square will be equal to 7 square plus 8.9 square. So GX will be 11.32 centimeter. So now I know all the three sides of this triangle GXF. Join the X point with the G and the F. The FX is 8.1. We just calculated somewhere. It's at 8.1. And here this is 11.32. And the GF is 8.8 centimeters. Sorry. And now you look at this triangle. We know all the three sides of this triangle. So I can apply the law of cosine to find out the GXF angle. So the cos of the GXF will be equals to 11.32 square plus 8.1 square minus 8 square. This will be in the numerator, and in the denominator we will write 2 multiply 11.32 multiply 8.1. So that is how you use the law of cosine. So just enter these values in your calculator and remember how you enter these values. In your calculator you will write 11.32 square plus 8.1 square minus 8 square equals to divide 2, divide 11.32, divide 8.1 equals to. So you will get 0.7075. So if you want to find GXF, that cos will go on the other side. The cos will become cos inverse. So the GXF will be equals to cos inverse of 0.7075. So you will have GXF equals to 44.96, which is when you round it off to two significant figures, it will be 45 degrees, and that is the answer. So this is how you will do this. It's a bit of question. So that was question number 8, and you can pause the video and let me reduce the size so you might be able to see the whole question together. Okay, so let me. Oof. So this whole question is showing up on your screen, so you can pause the video and you can play and you can take your time. Okay, so we are going to the next question. The next question coming up on your screen is question number 9. So we are on the question number 9. The P is the center of the upper face of a rectangular block with the ABCD as its base. So basically this is like a room, or it's like a box, and the ABCD is the floor. And on the roof when you join the top corners of the roof with each other, and the P is the point which is exactly on the top and is in the center of the room. So it's the intersection of the diagonals which are joining at the ends of the roof with each other. So the height is 5 centimeter and the AB side is 12 centimeter. The BC side is 16 centimeter. They want us to find out the PAC angle. So that will be a triangle if you join the P with the A and P with the C. And uh, for that purpose, first of all, I will join the A with the C. So it will be a ABC triangle. That will be a right angle triangle. And I know the AB side, that's 12, BC side, that's 16. I will apply the Pythagoras. I will find the AC. So the midpoint of the AC will be exactly below the P. So we can call it P prime. And then we can solve this and we can find the PAC angle. Okay, so here we go. So first of all, I will take that rectangle ABCD, which is the floor, and I will find the AC side. I will apply the Pythagoras on the ABC right angle triangle, and I will have AC square will be equals to 12 square plus 16 square. So that will be AC will be equals to 20 centimeter. And the A prime P will be half of the AC. So the AP prime will be AC divided by 2, and that will be 20 divided by 2, and that will be 10 centimeter. So then I will consider that triangle, that APC triangle, and this APP prime is a right angle triangle. So this angle PAC, I want to find out this. I know this height PP prime, that is 5 centimeters. I know the AP prime, that's 10. So I know the perpendicular, I know the base. I want to know this angle. So I can apply tan. So the tan of the PAC will be 5 by 10. So the PAC will be tan inverse 5 by 10 bracket close, and that will be 26.6 degrees. So this is how you will do the A part of the question number 9. I hope you understand. The next question they ask us is find the PAB angle. So I need to know the APA side, and I need to know the PP side. Whatever will be the PA, same will be the PB, and I know the AB 12. So this will be a triangle APB. And then by using the law of cosine, I will be able to find out the PAB angle. Okay, so let me show you. Okay, so the PAB angle, first of all, by using this triangle, I will find out the AP side. So the AP, apply Pythagoras here. So you will have 5 square plus, let me show you. AP whole square will be equals to 5 square plus 10 square. So AP will be equals to under root of the 125, and that will be 11.18 centimeter. BP will be also same. It will be 11.18 centimeter. Now I will consider the triangle APB. AP is 11.18. APB is 11.18. The AB side is 12 centimeter. It's a iso triangle. So by using the law of cosine, I can find out this angle, and it will be 11.18 square plus 11.18 square minus 12 square. And this will be in the numerator. In the denominator, I will write 2 multiply 11.18 multiply 11.18. And the cos of the APB will be equals to, when you do that calculation, you will get 0.42396. And how you do this in your calculator? In your calculator, you will write 11.18 square plus 11.18 square minus 12 square equals to divided 2 divided 11.18 divided 11.18 equals to. You will get 0.42396. Then the cos will come to this side, and it will become cos inverse. So in your calculator, shift cos 0.424 equals to, you get 64.9 degree. So the APB angle will be 64.9 degree. So actual question is PAB angle. So this is alpha, because these two sides are equal. So it's an iso triangle. So this angle, suppose it's alpha, this angle will be also alpha because it's an iso triangle. These will be the base angles of the iso triangle. So you will have alpha plus 64.9 equals to 180, and 2 alpha will be equals to 180 minus 64.9, and that will be 115.1 divided by 2, and you get alpha equals to 57.6 degrees. So the angle PAB will be equals to 57.6 degrees. So this is how you will do this question. And let me show you, reduce the size so you can see the whole question. So the whole question is the whole question is showing up on your screen. So this is how you will do this question. So that was question number 9. So okay, so we are going to the next question. The next question is question number 8, question number 10, sorry. And it says P, Q, and R are the 3 points on the level ground with the Q due east of the P and R due south of the P. A vertical mast PT stands at the P and the angle of the elevation of the top T from the Q is 3.5 degree. Given that the PQ is 1000 meter and the PR is 750 meter, find the bearing of the Q from the R. That's the first question. So let me show you how this is done. So basically, okay. So this is question number 10. So there we have the P in the east, we have Q, and that's 1000 meter away, and exactly below the P in the south of the P we have R, which is 750 meter away. So the bearing of the R from the P is 90 degree because it's in the south. In this direction we have the north. The Q, sorry. The bearing of the R is 180 degree. The bearing of the Q from the P is 90 degree because it's in the east. And so this angle will be also 90. So basically they are asking you to find the bearing of the Q from the R. So it's a right angle triangle. I know this is 1000. I know this is 750. This angle, when you go from this north to clockwise to the RQ line, that will be the bearing of the Q from the R. So I want to know this angle. So this is a right angle triangle. I can find this angle, apply tan. Tan of the PRQ angle will be perpendicular by base, and that will be 1000 divided by 750. So the PRQ will be tan inverse of the 1000 divided by 750, and the bracket will be closed, and that will be equals to that will be 53.1 degree. So this I just wrote something wrong here. The actual number is 53.1 degree. So the bearing of the Q from the R will be 53.1 degree. Just ignore this number. By mistake, I have written this number. The actual number is 53.1 degree. So the bearing of the Q from the R will be 53.1 degree. Just ignore this number. This is some mistake. Okay. By mistake, I wrote this number. So this is how you do this. The next part, the B part, second part, he says the height of the mast. Okay. So I know the angle of the elevation of the top of the mast point T from the Q, that's 3.5 centimeter. So the PQ side is the yeah, the PQ side is 1000 meter, and this is the mast PT. The angle of the elevation of the top of the T from the Q is 3.5 degrees. I know this. This is a right angle triangle. Acha. So I know this, and this PQ, that's 1000, and I know this angle. I want to find out this. So the tan of the 3.5, height of the mast, tan of 3.5 will be the PT divided by 1000. So the PT will be equals to 1000 multiplied tan 3.5, and the PT will be 61.16. So that's 61.2 meter approximately. Okay. So this is how you find the height of the mast. Then they will ask you the angle of the elevation of the T from the R. Now I know the height of the mast PT. So I will consider the triangle TPR. I know the PR, that's 750. I know the height of the mast PT. That's 61.2 meter. We just calculated in the upper part. And I want to know the angle of elevation. So the angle of elevation is this from the R of the point T, which is the top of the mast. And I can apply the tan. Tan PRT will be equals to the perpendicular by base. That's 61.2 divided by 750. And so that will be PRT angle will be tan inverse of 61.2 divided by 750 bracket close. And that will be 4.665 degrees. So that when you round it off, it will be 4.7 degrees. So this is how you find the angle of the elevation of the top of the mast from the point R. So let me reduce the size. So this is how you will do this question. This is question number 10. The whole question is showing up on your screen. So you can pause the video and you can take your time with this. Okay, so we are going to the next question. The next question coming up on your screen is question number 11. He says, the figure shows 4 points O, A, B, C, which lie on level ground in a campsite. O is due north of A and B is due east of O. Okay, so this angle here is 90, this is 30, this is 28, this is 70, this is 50 meter. The question is given that the OA is 28 centimeter, OB is 30 meter, and OC is 50 meter, and the BC is 70 meter. Find the bearing of the A from B. The bearing of the A from the B. So I can find this angle. I will make a north here, and from that north, I have to find out this angle. Okay. So that is the question, the bearing of the A from the B. So the strategy is simple. Okay. So here you can see I have made this diagram. So this is that triangle. First of all, I will find this angle. Uh, this is angle alpha. This is 90. This is north here. The B is in the east of the O. So this bearing is 90. So I draw north here. These two angles are allied to each other. This is angle alpha. Alpha plus the 90 will be equals to 180. They are the allied angles. So the angle alpha will be also 90. Then I will find this angle. This is a right angle triangle. I want to know this. This is my perpendicular. This is my base. So I will apply the tan. So the tan of the 28 divided by 30, and that angle of the this is gamma. Sorry, this gamma, I will find tan gamma is equals to 28 by 30. So the gamma angle will be tan inverse of the 28 divided by 30 bracket close. That will be 43 degree. So I know this is 90. This is 43. So this angle, you want to find out the bearing of the A from the B. So on the B, we will have the north. From that north, you will go clockwise to the BA line. So I want to know this angle beta. So the sum of these three will be 360. So the alpha plus beta plus gamma will be 360. So the beta will be 360 minus alpha minus gamma. So 360 minus 90 minus 43, and beta will be 227 degrees. So the bearing of the A from the B will be 227 degrees. So let me show you the whole thing. So the whole the A first part is showing up on the diagram on your screen. So this is the strategy, and this is how we will execute that strategy. So that was the first part. Then he says find the angle COB. So COB angle is a triangle. You see COB is a triangle. I want to know this angle. I know the three sides of this triangle. So by applying the law of cosine, I can very easily find out this angle. So I will find out that angle COB. The cos of the COB will be equals to 50 square plus 30 square minus 70 square. That will be in the numerator. And in the denominator, you will have 2 multiply 50 multiply 30. So when you enter this value in your calculator, you will write 50 square plus 30 square minus 70 square equals to divide 2, divide 50, divide 30 equals to. You will get minus 0.5. So that cos will come to this side. So the COB angle will be cos inverse of the minus 0.5 bracket close equals to, and that will be 120 degrees. So the angle COB is 120 degrees. So this angle is 120 degrees. Then the question is the bearing of the C from O. The bearing of the C from O. So here we will have the north. From this north, I will go clockwise to this angle. So I have to find out how much is this angle. Okay. So on your screen that is showing up, and so on the O I will draw a north, and this whole angle is 120. This angle we know is 90. I want to know how much is this angle. So this angle here, only this angle, that is x. So that x will be 120 minus 90. So that will be 30. So from 360, if you subtract the 30, you will have this angle. From north, go clockwise to the OC line. So that will be the bearing of the C from the O. So the bearing of the C from the O will be 360 minus 30, and that will be 330 degrees. Okay. Now we have a B part also there. He says a vertical flagpole stands at the point B such that the angle of the elevation from O, A, and C are measured. Given that the greatest angle of these three angles of the elevation is 29, calculate the height of the flagpole. So the greatest angle of the elevation is 29. The greatest angle of elevation will be from that point whose length from the B is, whose distance from the B is smallest. You see, first of all, I will find out how much is the length AB. I want to know how much is the length AB. So I will apply Pythagoras on these two. So to find out what is the distance between B and A. So AB square will be equal to 30 square plus 28 square. So AB will be equal to 41 meter. So now I know that the distance of the AB is 41 meter. The shortest distance is of the point O, which is 30 meter. So, from the O, the angle of elevation will be maximum, and that is 49 degree. So take that right angle triangle OBF. BF is that vertical pole, and I want to know its height. So I will apply the tan 29 will be equals to the BF divided by the 30. So the BF will be equals to 30 multiplied tan 29, and that will be 16.6 meter. So this is how you will do this question. This part was little tricky. First of all, I need to know from the OB, AB, and the CB. So whichever distance is the smallest, so from that point, the angle of the elevation of that vertical pole will be the greatest. And that was the point O. Okay, so this is how you do this question. These questions are easy, but your imagination should be very good, because this is, see, so that is the question number 11 showing up on your screen. You can pause the video and you can take your time. Okay, so we are going to the next question. That is question number it's kind of the same question. Question number okay, question number 12. So A, B, C, and D are the four points on the horizontal ground. B is due south of A, and the bearing of the C from A is 90 degree. So I know this is a right angle. It's 80 is 60. I can find the BC in this triangle. I know all the three sides. This is exactly the same question as question number 11. Given that the AB is 60 meter and the AC side is 80 meter and the CD side is 150 meter. Find the bearing of the C from the B. This is north, so this is north. So I want to know this angle basically. That is the bearing of the C from the B. And this is right angle. I can very easily find this angle. You can apply the tan. So tan theta here will be 80 perpendicular by base. That will be 80 divided by 60. Let me show you. So here we go. So I will apply the tan ABC will be equals to the 80 divided by the 60, and the ABC will be equals to tan of the ABC will be equals to the 80 divided by 60, and ABC will be equals to tan inverse, and that will be 80 by 60, and that will be 53.1. So this angle is 53.1, and this is the bearing of the C from the B. That is how you do the first part. Then he says the bearing of the D from the A. So very easy. I will find out first of all this angle by using the law of cosine, and then I will draw a north here, and then we will be able to find the bearing of the D from the A. Okay. So first of all, I will apply cos of the DAC, and that will be 80 square plus 90 square minus 150 square, and that is in the numerator. In the denominator, we will write 2 multiply 80 multiply 90, law of cosine. So in your calculator, you will write 80 square plus 90 square minus 150 square equals to divide 2, divide 80, divide 90 equals to. You get minus 0.555. So DAC will be cos inverse of the minus 0.555 bracket close, and you will get 123.75 degrees. So this whole angle, DAC angle is 123.75, and this angle is 90. So from 123.75 subtract this 90, you will get this angle, whose name is X, and that will be 123.75 minus 90, and that will be 33.75. So once I know the angle X, from 360 subtract the angle X, and you will have the bearing of the D from A, because the bearing of the D from A is from this north go clockwise to the AD line. So that will be 360 minus X. So that 360 minus 33.75 degrees. So you will get 326.3 degrees. So this is how you will find the bearing of the D from A. So question number A, second part, the whole question is showing up. A vertical mast stands at A, and the angle of the depression of the C from the top of the mast is 8.6. Okay, so find the height of the mast and the angle of the depression of the D from the top of the mast. Okay, so when you look at from the top of the mast, you look at the point C, and so this is how you do this ACT triangle. AT is that mast from the top. When you look at the point C, which is 80 meters from the point A, the angle of depression is 8.6 degrees. So you know the angle of elevation and angle of depression are the same, are exactly equal to each other. So this angle of elevation of the T from the C will be also 8.6. So I will apply tan, and I will find height of that mast. So tan 8.6 will be equals to 80, which is perpendicular, divided by the 80, which is the base. So the 80 will be equals to 80 multi 80 will be equals to 80 multiply tan 8.6. That will be 12.1 meter. So the height of the mast is 12.1 meter. Now the angle of the depression of the D from the top of the mast. So I will take the triangle, and that triangle is DAT. The DA distance is 9 meters. The AT, which is the height of the mast, that is 12.1 meter. We just calculated it. From here, I want to know how much is the angle of elevation, and the angle of elevation and the angle of the depression. They will be exactly the same. So I want to know this angle. Let me call it this angle as the angle phi. So the tan of the y will be 12.1 divided by 90. So the y will be tan inverse of the 0.134, and that will be 7.65. So when you round it off, that will be 7.7. So the angle of elevation of the T from the D will be 7.7, and the angle of the depression of the D from the T will be also the same, and that will be 7.7. So this is how you will do this question. So let me reduce the size. So my dear students, the size of these pictures are such. Okay, so the whole question almost is, so the whole question is showing up on your screen. You can pause the video and you can zoom in, and I hope you understand. This is how you do the question number 12. So my dear students, in this video, in this session, We have done from exercise 9C from the book D3. The name of the book is New Syllabus Mathematics, 7th edition. We have done from question number 7 to question number 12. So this is the second video, and the rest of the questions of this exercise I will do in my next video, which will be the third video on this exercise, and you will also find this video in the same place in my YouTube channel. So if you find this video interesting, useful, and helpful to you, please share the link of this video onto your Facebook account and onto your Instagram and onto your Twitter accounts. If you like this video, that will be a great appreciation for me and for my channel. It's a great blessing for me that I am able to help so many people around the globe through this YouTube channel. It's an honor for me. So thank you very much, everyone. Have a good day. God bless you all.